When installing a backup generator, especially for a residential service, understanding the correct transfer switch configuration is crucial. For a 100 amp service with 120/240 volts single-phase power and a backup generator, the question often arises whether a 2-pole or 3-pole transfer switch is adequate. A 3-pole switch is required to maintain a separation of the neutral conductor from each power source. The neutral conductor is a critical part of the electrical system, serving as the return path for current from all circuits. It's essential to prevent this neutral conductor from being energized by more than one source of power simultaneously. If the neutral becomes energized by multiple sources, it can create a hazardous situation, potentially leading to electrical shock or equipment damage. In the specific scenario of a backup generator, the neutral conductor must be kept separate from the utility's neutral conductor. This separation prevents the generator's neutral from becoming energized by the utility's power. Such a situation could arise if the utility power is still active while the generator is running. If the generator's neutral is energized by the utility's power, it can create a backfeed condition. A backfeed occurs when the generator sends power back into the utility grid, which is dangerous for utility workers and can damage equipment. The 3-pole safety switch ensures the loads are safely transferred between the utility and the generator. The 3-pole switch disconnects both the hot conductors and the neutral conductor from the utility when the generator is activated. Simultaneously, it connects both the hot conductors and the neutral conductor to the generator. This action guarantees that the neutral conductor is always isolated from the utility's power. This isolation is important for preventing backfeed and ensuring the safe operation of the generator system. When selecting a transfer switch, ensure it is appropriately rated for the amperage of the service. In this case, a 100 amp rated switch is suitable. Consider the load that will be connected to the generator. In situations where the generator capacity is limited, like a 5 kilowatt generator, it is important to manage the emergency loads carefully. A manual transfer switch is often preferred in these situations, as it allows the user to selectively connect and disconnect loads. Automatic transfer switches are better suited for scenarios where the generator has sufficient capacity to handle the entire load. Always refer to the National Electrical Code, or NEC, for specific requirements and guidelines related to generator installations and transfer switches. The NEC provides detailed information on proper wiring methods, grounding requirements, and safety measures. It is also important to consult with a qualified electrician to ensure that the installation meets all applicable codes and regulations. Proper grounding is another essential aspect of generator installations. The grounding system provides a low impedance path for fault currents, helping to protect against electrical shock. The generator should be grounded in accordance with the NEC requirements. This typically involves connecting the generator frame to a grounding electrode, such as a ground rod. The neutral conductor should also be bonded to the grounding system at the generator. Bonding means intentionally connecting the neutral conductor to the grounding electrode system. This bonding helps to ensure that the neutral conductor is at the same potential as the ground, reducing the risk of electrical shock. When wiring the transfer switch, it is important to use the correct wire size and type. The wire size should be appropriate for the amperage of the circuits being served. Use conductors that are suitable for the environmental conditions where the installation will be performed. For example, if the installation is in a damp location, use moisture-resistant conductors. When making connections, ensure that all connections are tight and secure. Loose connections can cause overheating and create a fire hazard. Use appropriate connectors and terminals for the wire size and type. After the installation is complete, thoroughly test the system to ensure that it is working properly. Verify that the generator starts and runs smoothly. Check that the transfer switch operates correctly and that the loads are properly transferred between the utility and the generator. Use a voltmeter to measure the voltage at various points in the system to ensure that it is within the acceptable range. Also, use an ammeter to measure the current draw of the loads to ensure that the generator is not overloaded. If any problems are detected, troubleshoot them immediately and take corrective action. Always prioritize safety when working with electrical systems. Wear appropriate personal protective equipment such as safety glasses and gloves. Energize circuits before working on them whenever possible. If you are not comfortable working with electrical systems, consult with a qualified electrician. Following these guidelines will help to ensure a safe and reliable backup generator installation. Firstly, understand the function of a 3-pole transfer switch, as its third pole is used to switch the neutral conductor. Secondly, ensure complete isolation of the neutral conductor from the utility when running on generator power. Thirdly, prevent backfeed into the utility grid, a serious safety hazard. Fourthly, protect electrical workers and equipment from potential damage. Fifthly, adhere to NEC requirements for grounding and bonding. Sixthly, ensure correct wire size and type for all connections. Seventhly, make all connections tight and secure to prevent overheating. Eighthly, test the system thoroughly after installation. Ninthly, verify proper voltage and current levels. Tenthly, prioritize safety at all times when working with electrical systems. Understanding these aspects is critical for any generator installation. Proper selection and installation of a 3-pole transfer switch is not just about meeting code requirements, it is about ensuring the safety and reliability of the entire electrical system. This protection extends to the homeowner, utility workers, and the electrical grid itself. The small additional expense and effort of using a 3-pole switch is a worthwhile investment in safety and peace of mind. When working on these installations, always consider the potential hazards of electricity. Even seemingly minor mistakes can have serious consequences. A thorough understanding of electrical theory, code requirements, and safe work practices is essential. Never hesitate to consult with a qualified electrician if you have any doubts or questions. In summary, choosing a 3-pole transfer switch for backup generator is the correct approach for maintaining neutral isolation, preventing backfeed, and ensuring the safety of the electrical system.